Good morning, students. I hope you are doing well. It's the beginning of the term. So, how are you? You good? Okay, so let's start. Today, we're going to learn about a topic called liquid pressure. But before we start that, we have to go to the previous class's topic, that is pressure. So we will review that part first with you, and then we will proceed to the new topic called liquid pressure. Okay? Okay. So first of all, can you tell me what is liquid pressure? Sorry. Can you tell me what is pressure? So pressure is force per unit area, as you can remember. So if there is an area and on that area a force is applied, then we call it pressure. For example, if P is the pressure, then P is equal to force divided by area, that is pressure. Now, what is the unit of pressure? The SI unit of pressure is Pascal or Newton per meter square or Newton per square meter. For example, the unit of force is Newton and unit of area is meter square. From the formula, we can say that pressure is equal to, remember, unit of pressure is equal to Newton, that stands for N, and meter square divided by meter square, which is the unit of pressure, or we can call it as Pascal. We can represent it by PA, Pascal. Okay, so let's go for the next. As you can see in the board, the unit of pressure is, the equation of pressure is P equal to F divided by A, where P represents pressure, F represents force, and A represents area. Now, as you can see in the board, there is a picture. In one picture, the bottle is upside down, and the other picture, the bottle is normal, in a normal stance. There is a molding clay. So as you can see, the upside down bottle has more pressure exerting on the clay. Why? Because the area of the bottle is very less, but the weight is same. Now, if I draw it here, for example, we have a plate, and here is the bottle. Let's see. It has some amount of liquid in it. The liquid will apply some downward force. The area, this is very small, this amount of area. Here, the pressure will be force divided by area. Remember, on the other case, on the other one, again, the bottle is in a normal stance. So it is like this. The liquid in both cases are same. So that means what? The weight of the bottle is same. But in this case, the area that is connected with the clay is different. So therefore, we will have different amount of pressure. Since as you can see, that area 1 is much more smaller than the area 2. That means what? The pressure will be bigger than the second one. So, for example, let's say the weight of both the bottles are around 5 Newton. Both the bottles have same amount of force, downward force. For area, this is a very little amount of area. For example, let's say around 2 meters square. But the other one has a bigger area, let's say 5 meters square. Then what will be the formula? According to the formula, the pressure exerted by the bottle 1 will be force 5 Newton divided by meter square. That means 2.5 Pascal. In the other case, the force is same, but the area this time it is much more bigger area. So the amount of pressure it will exert, that will be 1 Pascal. So that means since 2.5 Pascal is bigger than the 1 Pascal, that means pressure exerted by the bottle 1 will be more than the pressure exerted by the bottle 2. In this case, it will be 2.5 Pascal. In this other case, it will be only 1 Pascal, because it depends on the amount of area. Next. So everyone understand? Any questions till now? So before we go to the next topic, let's talk about what is pressure. Pressure is force divided by area. Remember, force per unit area. The SI unit of pressure is Pascal, PA, and or we can say as Newton per meter square. Pressure depends on the amount of force the bottle is exerting, that is F, and also depends on the area on which it is exerting the pressure. Now, if area is smaller, then the pressure will be more. If area the force is exerting is more, the pressure will be less. Okay, so let's go to the next topic. Today's topic, that is liquid pressure. Now, what is liquid pressure? Let's start. So, what is liquid pressure? When an object is in a liquid, the liquid exerts pressure in all the directions, and that is called liquid pressure. For example, let's say we have a big beaker and it is filled with any kind of liquid. Now, we will have an object inside it. Let's say this is the object that is inside the liquid. This object will be exerted with force by the liquid from all the different directions. It will feel force. That force that is exerted by the liquid on the object from all the directions is called liquid pressure. Now, this liquid pressure depends on two important things, that is the density of the liquid. So what type of liquid is this? Density of the liquid. Another thing is called depth of the liquid. Density, that is represented by rho, and D is represented by H. So if this is the object, so the depth will be from the top of the liquid at where the object is placed. That is depth. And what type of liquid is this? It is represented by density of the liquid. So liquid pressure depends on two important things: density of the liquid and depth of the liquid. So what is the formula for liquid pressure then? The liquid pressure is represented by P, liquid pressure, which is equal to rho Z H. Rho Z H, where rho is the density of the liquid, Z is the gravity, and H is the depth of the liquid. Now, as you can see, a scuba diver is diving under the water. His body will be exerted force from all the different directions. That means he is experiencing liquid pressure under the water. Now, everyone understand till now? Any questions? No? Okay. Should I say what is liquid pressure one more time? Okay. So, one more time. If an object is under the water, this object will be exerted force by the liquid or water from all the different directions. That is called liquid pressure on the object. It will depend on two important things. First is the density of the liquid. What type of liquid is that? And another thing is depth of the liquid. That means liquid pressure P is equal to rho Z H. Rho represents density of the liquid, Z represents gravity, and H represents depth. Now, few important points about liquid pressure. At all points at the same depth in a liquid, under liquid, all points at same depth in a liquid under the same pressure. What does it mean? So, let me draw another picture so that you can understand. Let's say we have a beaker with uneven plane. We have liquid up to this level in this beaker. We have three different objects: object 1, object 2, and object 3. They are all at the, as you can see, are at the same level. The important thing is depth is same. We do not represent the depth from the below. It is always from the above. Okay, so depth is same. Another thing, it is the same liquid. That means what? The density is same. When density is same, when depth is same, we have another thing, that is gravity. Depth, density are same. That means for all the three different objects, the pressure P1, P2, and P3, the liquid pressure on the objects will be same. At the same level of water or liquid, all the three objects will experience same amount of liquid pressure. So that is what the point 1 is same. Point number 2. Liquid pressure does not depend on the shape and the size and the surface area of the container. So, liquid pressure do not depend on the shape of the object. It does not depend on the size of the object, or does not depend on the surface area of the container. For example, we have 3 different objects again now in this liquid at the same level. So for example, let's say we have a rectangle size object, a triangle size object, and a spherical size object. The surface of the objects are different designs. So 3 different shape, 3 different sizes object, and 3 different surface of the object, surface area. All the 3 objects will experience same amount of liquid pressure. It does not depend on the shape, it does not depend on the size, it does not depend on the surface area. It will only depend on the density of the liquid and the depth of the liquid. Other than that, it does not depend on anything. It does not depend on the shape, size, and surface area of the object. Next, as you can see in the picture, similar to this one, there is another beaker. It will have 3 different objects. Let's say 2 different type of fishes are there. Which one will experience more pressure? Which one of the object will experience more liquid pressure? Object B or object C? Can you tell me? Correct. Very good. Both B and C will experience same amount of liquid pressure. Can you tell me why? Very good. Very good. Yes, correct. So that means both objects are at the same height. Same depth. And they have the same liquid. That means the density of the liquid is also same. That's why both the fishes will experience same amount of liquid pressure, since it is at the same depth and at the same type of liquid with same density of water of the liquid. That's why they are experiencing same amount of liquid pressure. Next, before we go to the next, let me erase this page. Okay. Now, what do you observe in this picture? There are 2 objects in this picture. One, the blue color cube is at a lower depth, and the pink color cube is at the higher depth. Now, what is the formula for liquid pressure? P is equal to rho Z H, right? Now, the liquid is same. That means rho, the density is same. That means it is constant all the time. Gravity does not change. It will also remain same. What is only changing? The depth. Depth is only changing. When the depth is less, the liquid pressure will be less. When the depth is higher, the liquid pressure will be higher. Very good. So as you can see, now the first object will experience less pressure and the second object will experience more pressure. Now in this case we have 3 different holes. Hole 1, hole 2 and hole 3. Hole 1 is at a lower depth. Since the lower depth means less liquid pressure. Since less liquid pressure is there, so it will come out very little distance. The water will come out very little distance. In this case, the depth slightly increased. That means there is more liquid pressure on the wall of the bottle. That means the water will come out a little bit further. And at the highest depth, it will have the highest amount of liquid pressure. That means the water will come out the farthest in this case. Okay? Next, buoyancy. We talked about liquid pressure. Next topic is called buoyancy force. So what is buoyancy force? Let's start. Now, what is buoyancy force? It is the upward force that acts on an object that is completely or partly immersed in a fluid. Okay? That means what? Let's say we have a beaker. As you can see, it will have a liquid inside it. Again. Now we place a square shaped object in it. It is partly immersed in the liquid. So, what is the buoyancy force? It is the upward force that acts on an object. So, as soon as it goes down in the water or in the liquid, it will experience an upward force. This force is called buoyancy force. Okay? Understand? Now, since this object is there, it will not only experience the buoyancy force also, it will also have its weight that is acting downwards, force due to gravity, that is weight. And this is the upward force is the buoyancy force. Buoyancy force. This is the buoyancy force. Now, we have in this picture 3 different objects. As you can see, the ship, the wooden log, and the box. The ship is floating in this case. Why? Because the buoyancy force of the ship is bigger. The buoyancy force of the ship is bigger than the weight of the ship. Case 1. In this one, the buoyancy force of the ship is more than the weight of the object. That's why it is floating. Next, the object is in float because the buoyancy force of the ship is more than the weight of the object. Next, again, the wooden log will also experience buoyancy force. It will also have its weight that is going downwards. Try to take it down. But it will stay submerged. It will not float, not sink. It will just stay at the same level. That means in this case, in the case 2, the buoyancy force is equal to the weight of the object. If the weight of the object and the buoyancy force are same, it will not float, it will not sink. It will be just submerged under the water. And the last case, the box. In this case, as you can see, the buoyancy force is much more smaller than the weight of the object. So case number 3, the buoyancy force is very less than the weight of the object. What will happen in this case? It will sink under the water. The object will sink. So always remember, every object that is in water will not only in water, in liquid will experience buoyancy force. If the buoyancy force is more than the weight of the object, that is the downward force, then the object will stay float. If the buoyancy force and the weight of the object are same, then the object will stay suspended. That means it will not sink, it will not stay afloat. It will stay at the same level under the liquid. And when the buoyancy force is much more smaller than the weight of the object will sink. For example, now we will do a practice at the end. So everyone, please go to this link in your mobile phone. We will try to practice that. Okay? So what is it called? Density factor, float or sink. So we will have few objects and you will have to guess will the objects will stay afloat or it will have sink. Okay? So I will give you 2 minutes before we go to that and then we will practice this. Okay? So as you can see, everyone, are you ready? So let's start. Let's take the first object. Okay? If I put it here, as you can see, it is 2 10 watt coins are there. 10 2 watt coins are there. Okay? What is the weight? 44 grams of each object. Now, if we, put it here. Now, we need to measure. First, remember, buoyancy force. What is the weight of the object? That is 44 grams. Weight. Okay. Now, buoyancy force. Buoyancy force is represented by rho Vz. Here, the V represents volume of displaced fluid. Now, if we put this object in the water, it will displace some liquid. How much is that liquid? 6.3 centimeter cube. Now, we need to calculate how much is the buoyancy force there. So, first, volume of water is how much? Sorry, density of water always represent. Let's say this is water. The density of the water will be is 1. Give me a moment, please. Density of water. How much is that? As you can see, one gram per centimeter cube. Okay. or if I want to say in kg per meter cube, it will be 1000 kg per meter cube. So, density of water 1 gram per centimeter cube. Volume of displaced fluid 6.3 centimeter cube. Gravity we will consider as 10. So what do we get? Centimeter cube gone. It will be 63 gram 63 gram meter per second square. Now 63 gram means 0.063 kg meter per second square, that is meter. Okay. Now weight of the object is how much? 44 gram. That means force is 44 gram 440 gram meter per second square. That means 0.44 Newton. Now, since 0.44 is more than the 0.63, the buoyancy force, what will happen? The object will sink as soon as we drop it. Okay? Now, it's your turn. Okay, let us try one more. So, in this case, always remember buoyancy force rho Vz, weight of the object is, we can measure, weight of the object is mass multiply gravity. Okay, mass of the object. Let's say we will take the second object now. The weight of the object is 2 gram. So that means 2 gram multiply gravity. That means 20 gram meter per second square. Let's keep it like that. Another case. Now, displace fluid. How much it is displacing? Measure the volume. What is the volume of the displaced fluid? It is 5 centimeter cube. So, since density is 1 gram per centimeter cube, displaced volume is 5 centimeter cube multiplied 10. So that means we will get 5 gram meter per second square. Now, as we can see from equation 1 and 2, the force due to gravity is much more bigger. Sorry, 50 gram. So force due to gravity is much more smaller than the force due to buoyancy. So what will happen to the object? It will sink or it will float. Since the buoyancy force is more, that means it will stay afloat. Okay? Let's try one more. Last one. Again, we will have an egg this time. Okay? First, always represents weight. What is the weight then? Mass multiplied gravity. Mass is how much? As you can see, 60 gram. Multiplied gravity, 10 meter per second square. So 600 gram meter per second square. That is the force due to gravity or the weight of the object. Now, if we want to measure the buoyancy force, rho v c. V is the volume of the displaced fluid. So how do we measure it? We will put the object in the liquid and it will displace some liquid. So how much liquid it displaces? It will displaces 50 centimeter cube. Gravity 10 meter per second. We know the density as 1 gram per centimeter cube. So centimeter cube gone. So what will remain? 50 multiplied 10. That is 500 gram meter per second square. Now what do we see from both the equations? As we can see that the force due to gravity or weight of the object is bigger, 600 gram, which is bigger than the force due to buoyancy, upward force. So what will happen? The object will float or it will sink. According to the equation, it will sink. Let's see. Correct. So it will sink. Okay. So I will give you a task. That will be your work now. So for the last 4 objects, you will have to find out the objects will sink or float. First object is a stone. Will the object will sink or not? You will have to measure it according to the formula. Write it down in your book and bring it. Okay. The second object is similarly, the second object is a duck, a ball, a crown, and a bottle of water. So all these objects, you will have to measure the force due to gravity, that is the weight of the object, and force due to buoyancy, that is the upward force of the object when it is in the liquid, and then determine will the object sink or float for the last 4 objects. That will be your homework. Okay, so before we finish now, again let's go back. So what did we learn today? We learned about pressure. So what is pressure? Force per unit area is pressure. The SI unit of pressure is force divided Pascal, and it is also represented by Newton per meter square. The equation for force is P is pressure is P is equal to force per unit area. Okay. As you can see, we have 2 objects. We have 2 bottles. One is upside down, and another one is in normal condition. Upside down bottle has more pressure because it is exerting the force on a very little amount of area. On the other case, the bottle has exerting less pressure on the clay because the area it is in contact with is more. Next, liquid pressure. So what is liquid pressure? When an object is in liquid, the liquid exerts pressure on the object from all the directions, and that is called liquid pressure. Liquid pressure depends on 2 things, that is density of the liquid and depth of the liquid. So liquid pressure is represented by P is equal to rho Z H. As we can see, a diver is in the water, under the water, and the water will exert force on the diver from all the directions. and that is called liquid pressure. Liquid pressure will remain same if the object is at the same depth. At the same level of depth, the object will experience same amount of liquid pressure. The liquid pressure does not depend on the shape of the object, size of the object and surface area of the object. If it is at the same level, does not matter what type of object it is, what size of object it is, or what shape of the object it is, it will always experience same amount of liquid pressure. For example, we have two fishes at same level. Both fishes will experience same amount of liquid pressure. Why? Because they are at the same level of depth. And the liquid is also same. That means the density of the liquid is same. That's why the liquid pressure on both the fishes will be same. Next, we have another example. Two cubes. One is blue cube, one is pink color cube. The blue color cube will experience less pressure and pink color cube will experience more liquid pressure. Why? Because there is a difference in depth. The pink color cube has more depth, that means more liquid pressure. The blue color cube has less depth, so less liquid pressure. Similarly, three different holes are at three different depths in the bottle. When the depth is less, the liquid pressure on the wall of the bottle is also less. That means the water will travel from that hole a less amount of distance. As the depth increases, the liquid pressure on the wall of the bottle will also increase, and as a result, the water will travel further and further as the depth increases. Last topic we talk about is buoyancy. So what is buoyancy? Buoyancy is the upward force exerted by the liquid on the object when it is slightly submerged, float or under the water. Does not matter. It will always experience an upward force. For example, the ship will experience an upward force. The wooden block, the wood will also experience an upward force, and the box will also experience an upward force. Now, if the upward force, that is the buoyancy force, is more than the weight of the object, then it will stay afloat. If the upward force or the buoyancy force is same as the weight of the object, it will stay suspended or just submerged under the water. It will not sink, it will not float. And last one, if the buoyancy force is less than the weight of the object will sink under the water. Okay? Remember, go to the website or go to scan the QR code and you have to find out for the last 4 objects. Okay? That is your work. So, I will check your answers in the next class and you will have to give me the results as in the board. Remember, first you will have to determine what is the weight of the object. For example, with the stone, what is the weight of the object? What is the weight of the stone? What will be the buoyancy force if it is on the water? And then you have to determine will the object sink or float. Same, according to this, you will have to find out your answer and then write down your answer. Okay, and submit it by next week. So thank you very much. See you in the next class. Thank you.